Okay, problem three is shorter and super fun. O sea, like you have a mouse, and this mouse can be in A, B, C, or D. And so, like, we want to see what are the possible transitions that this mouse can make. So, for example, again, we're gonna do a matrix, and this matrix is gonna be like, you know, it's gonna be A, B, C, D, and A, B, C, D. And remember, I want my columns to add up to one. So that means that here is like my from, and this is my to, no? So if I start in A, if my mouse starts in A, I can only go to B. No, I can only transition from A to B. So if I start in A, I have 100% of probability of going into B in case of a transition. No, if I am in B, I have four gates, and those four gates is the two of them bring me to A, one to C, and one to D. So if I'm gonna transition uh, from B to A, I have 50% of probability. From B to C, I have 25% of probability, and from B to D, I have 20% of probability. No, because I am moving around the room. Then from C, I have 50 and 50 to go to B and to D. So 0 to A, 50 to B, and 50 to D. And from D, I have 50 to go to B and 50 to go to C. So this would be my transition matrix. Is the from the mouse moving in the maze. And now if I want so this would be the answer for part A. And now for part B, I just want to find the steady state of this matrix. Is the And what is the probability that the mouse goes to room B? So I need to create a matrix with 4 rows, 4 columns. And it's gonna be 0, 1, 0, 0.5, 0, 0.25, 0.25, 0, 0.5, 0, 0.5, 0, 0.5, 0.5, 0. And because I want the steady state, I am gonna take it to a large power. Let me do it to the power of 50. And look, every column is basically the same. If we round them up, o sea, this is point 0.2, 0.2, 0.2, 0.2, 0.4, 0.4, 0.4, 0.4, 0.2, 0.2, 0.2, 0.2, 0.2, 0.2, 0.2, 0.2, 0.2. O sea, so let's say that my steady state is, what is it? Zero point 0.2, zero point 0.4. O sea, that means that my steady state is zero point 0.2, zero point 0.4, zero point 0.2, zero point 0.2. O sea, this is the steady state. And now the probability that I go into B is 40%. No, o sea, that the mouse is coming into B is 40%.